independent agent that perform a unit of work or a collection of tasks and update the internal shared state of the graph, right? So your agentic workflows will comprise of multiple nodes, and these nodes are independent and they perform a unit of work. And after that, once they perform a unit of work, they update the internal shared state so that other nodes can reference their work, or other dependent nodes can take the information which is shared by these nodes, right? Edges. Edges connect two nodes. Similarly, in a graph, edges can connect two nodes. Here as well, the edges connect two nodes in your agentic workflow graph, and they create the flow of the graph execution by defining the direction. So these edges are always directed from one node to another, and in this way, they define the flow of the execution of your workflow. Okay. Let's move on to the next part. This is also one of the most important concept actually in the AI engineering domain, that is tool calling. So, how many of you have heard of tool calling before, or how many of you have done tool calling actually? If yes, you can type yes in the comments. Okay, okay. I think most of the people have not done. I guess, yeah, cool, no problem. Yeah, but that's true. MCP servers have tools. They provide a lot of tools to your AI agent to use, and it is very similar to that concept only. Here also we provide our tools to to the large language model, or basically to our AI agent, for them to use however they want, and that is actually called tool calling. Tool calling is the concept where large language models can understand the human message, and on the basis of the context, they decide which tool to call with the right parameter. So what you can do is that you can provide multiple tools to your large language model, and these tools are nothing but methods, right? We will define these tools as a method, and you can provide these methods to the large language model. When I say you provide these tools to the model, you have to tell the model that this is the tool, this is the description of the tool describing what it does, and these are the input parameters through which you can call this particular tool, right? And that is the whole concept of tool calling. You provide these tools to the large language model, and then the large language model decides how and when they want to call the tool, depending upon the user context. So if you will go ahead and ask some questions to the model, and if the model will think that they have to call a tool to get the answer to your question, they'll go ahead and they can suggest that they want to call the tool, and then the tool can be called with the argument provided, and the result can be sent to the user. And this is what we are actually doing here in this diagram. Now I'll go on with some actual example of tool calling. This is a dummy example here. What we are doing is that we have an AI agent and we are providing two tools, right? Tool one is add two numbers, meaning the tool one add two numbers provided, and tool two gives the length of the string, meaning given the string, it provides the length of that string, meaning how many characters are present in the string. So these are the two very basic tools which we'll provide to the AI agent, and we'll see that whether they can understand these two tools, and whether they can figure out that if a user asks the question, they are capable of calling tools or not, right? So this is the high level idea what we are doing. Okay, moving forward, these are the two tools which we described previously. The first is the add tool that basically add two integers. So we have provided the description of this add tool. This is how the large language model will understand what the tool does. So in the description, we have mentioned add two integers. The name of the tool is add, and we have also defined the schema through which the large language model will understand what what should be the parameter they have to pass to the tool. So the schema has two numbers, a and b. These two are the numbers, and what the function does, it returns the sum of a and b, which is clearly visible, right? Now on the right side, there is a second tool, which is the length tool. And the name of the tool is find length. The description is find the length of the string, which will be given to the model to so that they can understand what this tool does. And there will be a schema. The schema takes one input argument, that is a string, right? And what the method does, it returns the length of the string. And this is simple. These are the two methods, right? Now we'll bind our model with these two tools, or basically we'll provide our large language model with these tools, and we'll ask question to the large language model, and then we'll see what is the output provided by the model. And we'll ask a question where uh, that it will require the model to add two numbers and provide a length of the string. So our query will be designed in that manner. So let's see that. This is the input and the output. The input is add number 5 and 4, and also find the length of the string crocodile. And the output is the sum of 5 and 4 is 9, and the length of the string crocodile is also 9. So that is what we expected from a large language model. Now the thing is how it did what it did, right? So when we gave the our query that add number 5 and 4 and also find the length of the string crocodile, on the right side you can see that as an output there is a tool call, right? And in the tool call there are two tools. There are two tools which the large language model wants to call. The first one is add, with arguments a and b, which is 5 and 4. So the large language model is itself figuring out from the query that, hey, I think that in the query I want to add two numbers, and the argument should be 5 and 4, because the it looks like in the query that is the thing which they want, right? And it also figures out that I want to call one more tool with the argument string, right? Crocodile. So from the query, it is figuring out that the user wants to find the length of the string crocodile as well. So I'll call another tool. So the large language model can call these two tools and can get these answers from the tool, because the tool can perform these operations for the model and they can return the data, and then they can accumulate the response and return to the user in a natural language format, and that is what is being done. So this is the high level concept of tool calling. Now you can accept tool calling to be a lot more complex as well. This was a very simple example, but you can do a lot of things with tool calling. You can maybe provide a lot of backend APIs to the large language model and let them figure out how to call it, or maybe you can provide them with a lot of uh, methods that interact with your database and let the large language model call it. In that way, maybe you will not require to write any SQL queries, because the model will figure out like how to convert the query into the parameters and then call the database function and get the data from the table, right? So that these are the things which we can do, and tool calling make a major chunk of MCP. MCP functions in that way. They function with the help of the tools which is provided to your AI agents, and then they are free to make those tool calls however they feel like during when they are in action, right? So this is the overall idea of tool calling. So any doubts in tool calling? I saw that a lot of people have never used tool calling before. So did you get the gist what tool calling is? If yes, you can type yes. Otherwise, if there's any doubt, feel free to put that in the chat. Yep, it's like a function calling. That's true. Okay, one doubt by Abhishek. So the edges have some weight. What are the weights here? Like the weight between two agents? How can we define the weight? No, there are no weights. This is not a weighted graph. This is just edges. Edges only define the control flow, meaning how the workflow execution will move. And these are not weighted. Yeah, cool. I guess this answered your query. So let's move forward with our. So yeah, let's actually be what the agenda is. Ours is to build a retrieval augmented generation system, and now we'll start. We'll finally start building it. And what we'll start with is first we'll understand what a rack pipeline is and how we can build this from scratch. We'll also understand how you can build a vector store because Building a vector store is a very crucial part of a RAG pipeline. And then we'll also understand how you can perform a web search through tool calling, right? So the idea is that we want to build an agent from which we can ask question, and if the question is relevant, then they can answer from the through the RAG pipeline. If the question is not valid, then they can perform the web search and can get your answer. So that is the high level agenda. Now we'll see how you can build this, right? How you can build this workflow end to end. So this is the high level design of our RAG pipeline. What are we going to do is that we are trying to build an agent which will answer queries for an airline system. Airline system, you understand that an airline system can be like any company like Air India, Indigo, right? Singapore Airlines, anything like that. Okay. So our agent will try to answer question for an airline company, and that airline company we are calling it Swiss Airlines. So what we have here is that we have the FAQ documents of Swiss Airlines, where it's a big document where a lot of things are there regarding flight booking, air, airline reservation, airline schedule, right? Airport structure, airport stuff, flight schedules. A lot of things are there. All of these are there in the FAQ documents and the policy documents. We have that document with us. Now we want our agent to we want our agent to answer questions for this. So we want, if a user is coming, they don't have to go through these big documents and spend so much of time. They can directly ask questions to our AI agent or our agentic workflow, and they will answer the question from the document, right? And for that, we'll build a RAG pipeline. So the RAG pipeline is divided into two parts. The first is data indexing, or basically what we call it as a data collection, where we prepare the data. And the second is the data retrieval and the generation, where we get the data, right? Or basically we generate the answer to the question. So on the left side, you will see the documents. These documents are nothing but the Swiss airline FAQ and the policy documents. The first thing we'll do is that we'll convert these documents into vector embeddings and we'll store them in a vector database, right? So we'll get our vector database ready. After that, when a user tries to ask question to our agent, what we'll do is that we'll check that what are the top documents we can get for a user query, meaning what are the top k documents from where there is a highest probability for an answer to come for a user query, right? We'll get those top k documents along with the user query, and we'll send the user query and the top k documents to our large language model, and we'll let the large language model generate a response on the basis of that, right? Now you should be questioning that why are we generating a chunk if we have the entire vector database with us. Why to get the top documents? Why not to like send the entire vector database having all the data to the large language model along with the user query? And in that way, like we don't have to do anything. We can rely on the large language model to find the answer from the document and get the data in the response. This this is doable for small documents, but if you want to scale your solution, this can like does not have this solution does not have a potential to scale, and this can backfire, right? And why this can backfire, like can anyone answer that? Why sending the entire vector database as a context to your large language model is not a very good idea? Slow response? No, that's not the case. Large language models are really fast. These have billions of parameters, and then still they are like they manage to answer your question really fast. So latency is not the problem. They have enough of like, structure on their own, and they can like, work through it. Hallucination can be one of those things, but it is not the primary reason we do that. And I think that Tara Charan Sai is able to provide me the correct answer. That is the context window. That is the major problem why we are not sending a vector database, because every large language model has a context window. meaning that there is a limitation on how much data you can send to the model, or how much like how much data or how much query, how big your query can be at once while you are sending it to the model. So you can expect like like your laptop or a computer has a RAM which can store a limited amount of data at a particular time. Similarly, large language model has a context window which allows them to store a limited amount of data at a particular time, right? And that is why if we have huge documents, large documents with maybe millions and millions of characters and hundreds and thousands of pages and chunks, then it is always a good idea to get the top documents from those where the probability of your question being answered is very high, and you pass those documents along with the query, right? So in those cases, it doesn't matter how big the vector database is, your query being answered, the probability of your query being answered is very high by the large language model, given that your query is relevant. So if if I have built a rack pipeline on an airline company, then I cannot ask questions like how should I ace technical interviews, or can you tell me about graph data structures. Questions like these will not be answered because there will be no traces of these questions, or there will be no traces of the answers to these questions in the documents. And your they will not be able to get relevant documents from the vector database, and it will the model will hallucinate or provide with some wrong answers if you're not handling exception very well. So it's not very good idea. As long as your query is relevant to the base on which the rack pipeline is built, the probability of model your large language model answering your question should be high. Okay, so this is the basic pipeline. Now moving ahead, why do we use retrieval augmented generation? You should be asking, like, since these large language models are itself very large and they are trained on the corpus of web data, what, why should we use retrieval augmented generation? Like, what are the information we have to explicitly pass, which is not already there in the back of the mind of the large language model, right? They are able to answer anything. So one of the most important thing is the problem of knowledge cutoff. Knowledge cutoff is building and fine tuning a large language model is a costly procedure, and these companies who provide you their large language model like OpenAI, Google, uh Amazon, Anthropic, these companies spend a lot of their infra, lot of their money to train these large language model, and then lot of manual power to fine tune them and convert them into a chat model through which you can chat, right? And this is a time taking and costly procedure, and that's why it is not feasible for them to like train these big models on a daily basis. So it is probably done on a monthly or a quarterly basis, and that opens them to the problem of knowledge cutoff. So suppose if GPT-4 was trained 2 months back, then it might not have information to the events that happened maybe a week ago or 2 weeks ago. And in those cases, you'll have to provide the context to your model so that they can perform on these questions, or like they can do something, like they can answer the questions related to those events, right? Second thing is you need to reduce the noise. Large language models has a lot of noise, so it's very important that if you think that you have to perform your model on a smaller domain, or you have to ask questions on a smaller domain, you can provide the context explicitly so that though your model can be grounded on it, and they have an idea that okay, I know a lot of things, but for this time I have to answer on this specific topic, so I'll try to answer the queries on these topics only. The third thing is the private data. Um, a lot of you must be a working professional, and a lot of companies don't prefer to share their data publicly in Google and or other websites through other websites, and that is why these information might not be present on the internet or the World Wide Web, and that is why the large language model should not be able to go through them during their training procedure, and that is why they might not have any idea about these information, and that is why when you ask questions to these model on these information, they'll not able to perform the way you expect it to be. And that is why in those cases as well, you can build a rack pipeline and you can ground these models on those private documents, right? So that is the high level idea. That is the use cases where building a RAG pipeline makes sense. Okay, awesome. So this is a basic RAG pipeline. We divided it into two parts: data indexing and data retrieval and generation. I discussed this already. So the only thing I have done is that I have split these into two parts. The way I actually code this when I'll build the agentic workflow going ahead. So that is why I wanted the design to be very similar to what we are coding ahead. So that's why this design is here. You can spend maybe uh, 20 30 seconds on this one understanding, and if there is any question on this one, feel free to put that in the comments. Okay, you got the high level design. What it's here on the screen. If you are completely clear, you can type yes so that I have an idea that this is clear to all of you. How do the AI query in DB to get particular data? So the question is, the AI doesn't query in the vector database. We will get the relevant documents from the vector database through matrix multiplication, right? If you know how vector database or how deep learning works, it is nothing but a bunch of matrix multiplication happening. And in order to do that, your vector database is nothing but all these text is being converted into tokens or basically numbers, which is sparse in a high dimensional space. And like you convert your query as well into these vectors and you try to matrix multiply them to get the results. So that is the high level idea. A lot of maths is also involved in order to get the top vector documents, vector DB, top documents from the vector database. So yeah, that is it. And someone is saying my voice is not audible. Is my voice audible, or like if you're not able to hear me, just okay, my voice. Okay, cool. Cool. Why the data is stored in vector DB? Why not in SQL? So that's a good question because the large language models are deep neural networks, and the deep neural networks are not feasible or does not perform very well on the textual data. They perform well on numbers, and these numbers are in the range of 0 to 1 or 0 to 2, the small numbers. They perform well in small numbers, and that's why we convert our data into vector embeddings. These are numbers, high dimensional numbers. Might because in order to maybe present one word or a character, you need a series of numbers in a high dimensional space, which your large language model can understand. And that's why we use vector database. You can think of it, we humans understand natural language, these large language model understand vector database. And that's why it's important to convert it. Okay, a lot of questions here. Let's move on to the actual coding part, which we are waiting for so long. Okay, so this is the code block, so don't get offended that I'm showing only the code snippet. Once we go through the code snippet, I'll actually show the working demo as well. So don't mind. As we have designed earlier in the design which I presented before, the slide before, this is one of the method which is get vector chunks. And if I go back, you can think of that what this method does is that it pulls the text chunks from the document and convert them into the vector embeddings. So what was happening in the first block here is actually being done here in this code. Okay. So what we are doing is that we are getting the document, and the document is nothing but, as I mentioned, it's the FAQ document of a Swiss airline. So we are getting the content of the document in the first line of the code. After that, we are splitting the document into multiple chunks. These chunks are text chunks, remember, right? Because the document is a text document. So when we split it, it's a text chunk of multiple chunks, basically. Yes. So the document is nothing but a series of chunks, series of text data. We have split it. Now what we are doing is that we are converting this into embeddings, and embedding meaning we are converting them into the vector embeddings, which will be stored into our vector database. And for that we are using a model called text embedding small. So there are multiple different models which have their own algorithm to convert textual data into vector embeddings. This is one of the models. We are giving all our documents to this, and what in return we are getting embedding. And what we are doing, we are accumulating all the embedding data into a vector database, or basically an array of embeddings. And that's what this method gives. This spits out a vector database, and for us, that vector database is nothing but a series of vector embeddings stored at one place in a list. So that's what we are calling a vector database here. Second method is getting the relevant documents. Now you have a vector database, or basically you have the vector embeddings of the entire Swiss Airlines FAQ document. Now what you have to do is that you have to pick the relevant documents, as we mentioned before. We cannot send the entire vector embeddings or the entire vector database to the model. We have to pick the top documents. How we will do it? We will do it in this method. So you can see that the at the rate is actually what we do using in a matrix multiplication. So it's a shorthand operator of matrix multiplications, and using that we are calculating score. So what we are doing is that for the entire vector database, we are getting our user query and we are converting our user query into the vector embedding, and then we are seeing that for this user query, which is nothing but now a vector embedding, how many relevant documents we have. And in order to do that, we are scoring each of the vector embeddings with the help of our user query. And we are storing this in the score. And then from this, we are picking the top scorer document. So what we did is that for all the vector embedding documents, we saw which documents has the top score and we picked that. And here the value of k is 5, meaning that we are picking top 5 documents. On what basis the text splitting occur? For this demo, we are doing it in the form of a new line. So if there are new lines, we are splitting it into multiple chunks, right? And then we are returning this in the form of the documents, right? So what we have is that we have vector embedding of the documents, which is the top documents, and along with that we have their similarity score to understand what was the similarity score. And there is a reason that we are returning a similarity score of our document along with the content of the vector embedded document, and we'll see that in the slide ahead. The second slide is data retrieval and generation. Here what is happening is that we are getting the top documents which we uh, received in the previous function. We are also getting the user query. Now what we can do is that since we have filtered out the top documents from the vector database, we can use this top document as a context to the model, and we can pass the query and we can get the response. And this is what we are doing here. We are using an OpenAI GPT client. We are using the GPT-4 model for this demo, and in the context, we are passing whatever filtered relevant document we have, and the question is nothing but the query which we sent. And then we are hoping that since we have extracted the important documents and we are providing that as a context to the model should be able to answer the query on the basis of the context, and we are returning the response of the model. All right. Now there is a catch here, that why I have returned the similarity score. Was it needed or not? So this is the reason why I have returned a similarity score, because people uh, like to do experiment with your with whatever you try to build. So if you will go ahead and if you'll show this project to your friend, I guess for first one or two queries uh, they'll query some um, airline related questions like about, but maybe third or fourth time they'll ask something stupid which is not at all related to your airline's FAQs. They might ask, can you tell me about data structure? Just by curiosity, they can ask these questions. And in those situations, I don't want my application or my agentic workflow to fail. I want my agentic workflow to be smart and understand that hey, this question is out of the context of the vector database or the rack pipeline, and I should direct this to a web search so that instead of me answering this, instead of the large language model answering this on the basis of a rack pipeline, I'll give this question to the web search and let this question being answered through web, right? It's just like a Google search. Let this be answered and return to the user so that your agentic workflow doesn't fail. So if someone is giving some out of context questions, your agentic workflow will still be able to answer them. And in order to do that, you will need to understand whether your rack pipeline is able to answer this question or not, and how you should be able to answer, how you should be able to understand that. Can anyone tell me? Like if you have really like really be like maintained your concentration, you should be able to answer it. Like how we will able to understand that our rack pipeline can answer this question or not. Yep, Dilip is completely correct based on the score. So I told earlier that there is a reason that we are returning the similarity scores with the top documents. This is because to understand how relevant these documents are, right? If I ask some out of context question, even though I'm returning some top five most relevant document, but they will have a very low similarity score. The fact that we are returning the top scorer documents, they are still getting returned. We haven't added any threshold. And now here's the point: we'll add a threshold that hey, if in the top documents the score of all the top documents are below the threshold, then I can safely say that the question is out of context and my RAG pipeline cannot answer this, and I'll probably perform a web search for it. And that's where we'll introduce web search as a tool calling. And this is how this will look like. We'll use Tably Search. It's also an open source uh, API provider for web searching to your agentic applications, and you can define this as a tool. You can provide what how many results you want. You need to include the answer or not, and then you can pass your query to the to this web search, and then you can get the answer. So basically, this is a model generated tool call where you pass the query, and then you can invoke this tool call, and you can get the message as a search response, and you can return this. And we'll only execute this method when the score of our documents are below the threshold, right? I talked about a lot of things here. The final slide is filtering out the documents. I talked about threshold. So for this demo, we are specifying the threshold to be 30%. So for the top relevant documents, if the score of the documents are below 30%, I can safely say that my rack pipeline cannot answer this. And what I'll do is that I'll gonna perform a web search, right? And even though if the document have a relevant score of more than 30%, then I'll keep the flow as usual, and I'll let the large language model answer the query on the basis of the context from the picked from the RAG pipeline. This is the high level idea of what we are doing. Now, a lot of things I have not discussed here. This is the basic code base, a code snippet where we are filtering out the documents on the basis of score threshold. That should be understandable. If we still have some filtered documents after filtering it out by the score threshold, then we are answering the query. Otherwise, we are performing the web search. Now we can see this in action. Let me quickly stop sharing and let me share my code base. Okay, I'll quickly share my screen now. Okay, I hope my screen is visible. I'll just okay, cool. Is my screen visible? Is the code visible to every one of you very clearly? I want the code to be really visible, and that's what really important here. I want you all to understand the code snippet because this is the heart of what we have built, and there's no much use if you're not able to actually code it and build ourselves. So these are the libraries which we are importing. All of these libraries are open source, so any one of you can go ahead and import it. It shouldn't be a problem. I'm loading my environment variable so that I can make the calls to the large language models. We have already discussed these two methods, getting the vector chunks and getting the relevant documents in the slide. So I'll quickly go ahead. We have also discussed about answer query as well. So these are the three methods which we have. I'll quickly go ahead and I'll define them. After that, I have the perform web search method. I have also discussed that in the slide, that how we do it. This is the exact code I have basically uh, picked from here only. So I'll just copy it and put it in my slide for the reference. I can also define this. And now what I can do is that I can execute. And how I'll execute is there is some query which I'll gonna run. So I'm gonna first comment this query and I'll gonna run this one because this is a relevant query. The query says, should I reconfirm my flight? Now, seeing this query, you can guess that this is obviously related to a flight or an airline question. A person want to understand that they have to reconfirm their flight or not. Now, what should happen? I'll get some relevant documents from the vector database on the basis of this query, and there is some place where this query being answered. But for that, we have to understand the relevancy score. So I can run this and I can get some relevant documents here. It will take some time to fetch the relevant document from the vector store. It is done now. We can see the vector, threshold of these documents which we have, and this is the threshold, right? These are the document. There are 5 documents, so there are 5 scores: first, second, third, fourth, and fifth. And you can see that the threshold score is pretty high. 0.43 means 43%, then 39%, 35%, 32%, and 33%, meaning that these are really relevant documents and my RAG pipeline can answer the question. So I'll go ahead and I'll let the RAG pipeline answer it by invoking the answer query method. And the model responded with this success true, and content is no reconfirmation of Swiss flight is not required. So this is picked from the FAQ document, but we don't have currently the idea where this question was answered. The large language model is doing that for us because it now has the context which we have provided from the top K documents. Now what I can do is that I can ask some very irrelevant question which is nowhere related to an airline company. I'm asking how to make an Italian pizza. Okay, let me run this and let me see what are the relevant documents which the model returns. Okay, this has run and I have some relevant documents. I'll run it and we'll see what the relevant documents are. So I got relevant documents, but you can clearly see the scores are very low. It's 15%, 12%, 12%, 9%, and 10%. The similarity score are below 15%, like in the range of 10s and 9%, way below our threshold of 30%. So that's why what is happening is that no relevant documents found with the sufficient similarity score performing a web search. It performed a web search and it gave me an answer. To make Italian pizza, use high quality flour, tomatoes, and olive oil. Let the dough ferment for days for best flavor. Bake in a hot oven until crispy. This is how you make an agentic workflow. And this is a pretty decent workflow which can answer most of your questions, even though your friend comes up and try to experiment with it and try to let them answer some very vague question. They have a backdoor through which they can perform a web search and give you the result. If the question is relevant, they'll search the vector database and they'll give you the result. So a lot of things we understood um, with this demo. This is not just building an agentic workflow demo. From this, we understood how you can build a RAG pipeline. For that, how you can build a vector database, how you can retrieve relevant documents from your vector database, how you can check the similarity score, how you can understand that whether a question asked was relevant or not, right? How you can direct your workflow to perform different things on the basis of different scenarios, how you can perform a web search, right? A lot of things like I guess this tutorial alone involves 7 to 8 concepts of AI engineering, which are very core concepts like tool calling, RAG, vector databases, similarity scores, web search. A lot of things were there, and I hope this was helpful. What if the query is vague but relevant to the business model? Even if the query is vague and if it is relevant to the business model, it will get a very high similarity score because at the end of the day, you are checking the query on the basis of the vector database, which holds the data of your business model. So even though your query is vague, have grammatical mistakes, even though it's not very much understandable, but it has some meaning, it should get a good relevance score Why is flight flying? Yeah, that's a good question. Why is flight flying? Now, this question again, the if you will pass this question, you'll get some threshold, you'll get some score, and the score depends upon whether that question exists in your FAQ documents or not. And I strongly believe that this will not be there, and that is why, like, this question will not be answered in a business model in a FAQ document. That is why it will get a lower threshold, lower similarity score, and it might be answered from the website. So that's the whole idea. I will suggest, like, there should be a lot of questions coming uh, in my way. This was one of the question by Abhishek, which should, like, urge create an urge of building these workflows on your own and experiment on your own. There is a lot of way in which you can experiment and understand how these large language models think, how these large language models behave, what are the loopholes, where these agents can break, and how being you as a software engineer can fix that. And that's where you become a good AI engineer, right? Okay, I think we are at the mostly at the end of the session, and I'll quickly go back to my slide. Cool. Now let me cover a lot of small stuff here. I think we have a couple of slides to cover on why there is why now to become a GenAI engineer. So if the CEO of Google, Microsoft, and OpenAI say this is the next industrial revolution, then the question isn't should you learn GenAI, it's when, and the answer is yesterday. So you should have already started, and if it's not, you should get started. And let's talk real for a minute. Many of you are inspired, and that's